Hello wonderful person, this is Anton, and today we're going to be talking about a very unusual phenomenon that to some extent violates the laws of physics, at least the laws as we understand them today, and specifically the laws in regards to how bright a certain object can get. Because for some reason there are objects out there referred to as ULX or ultra-luminous X-ray sources that seem to be at least 100 to maybe 500 times as bright as they should be. Or not as they should be, but as they physically can be. Based on what we know about physics around us, none of these objects should be as bright as they are. And so in this video we're going to discuss some of the new discoveries, some of the propositions of what exactly is happening here, and discuss some of the recent discoveries from the paper you can find in the description that might have provided certain answers by looking at this relatively interesting binary system located in the galaxy M82 that contains a super bright X-ray object but also contains what's known as a neutron star, or specifically a pulsar. And the recent investigation might have figured out what is actually happening here. But I guess let's start with baby steps. So first of all, why exactly is this even a problem? Well, when it comes to things in space, specifically bright things in space, and here let's just imagine a typical star, we obviously know they produce luminosity, or they produce light. By itself, this light, and here we're talking about photons of light, doesn't just act as a wave, it also acts as a particle, but at the same time also provides a little bit of a push on any object they encounter. And that's of course how, for example, solar sails are able to work in space. Photons exert a small push and give that solar sail a little bit of propulsion. But obviously, the brighter the object, the more of this push it's going to provide to various objects. And so even the sun is able to push things around in the solar system, occasionally changing orbits of various asteroids, making the orbital predictions a little bit more tricky than they should be. This effect is known as the Yorp or Yarkovsky effect. But our sun is not powerful enough to do much more. Certain stars are though. There are stars that are hundreds, thousands, and even millions of times brighter than the sun. And at some point we can actually reach the amount of force produced by all of this light that starts to dramatically shift the gravitational forces trying to pull us in. In other words, while the gravity tries to pull things into the star, all of this light tries to push it out. And at some point we reach a kind of an equilibrium. In astronomy, this is known as the Eddington limit. The forces from the light are basically equal to the forces from gravity. Or just to rephrase this, something becomes so bright that the light pushes things away, counteracting gravity itself. Now obviously for this object to actually do this, it has to be super bright. But, as the scientists have discovered in the last few decades, these objects are out there and quite a lot of them exist for unknown reasons. But they also exist by producing light in different frequencies. But usually when this happens to, for example, a star, it basically just starts losing a lot of mass from the outer shell, producing something similar to what you see right here. This is a typical Wolf-Rayet star, where the brightness is usually much higher than the force of gravity. And so in these super Eddington luminosity stars, it essentially results in very powerful solar wind that strips the star of its mass and eventually reduces the total luminosity, stopping all of this at some point in the future. Other famous examples where Eddington limit is crossed are things like supernova, regular nova, and of course gamma ray bursts. But in this case, all of this only lasts an extremely short time. There are, however, various minute X-ray sources, and even various active galaxies, where this limit can be maintained for a very long time, although very often not actually crossing that far into it. Basically here a kind of an equilibrium is reached for thousands and even millions of years. This is very often driven by some kind of a black hole in the middle, where the accretion disk around the black hole generates such a tremendously powerful amount of light that it literally starts to counteract the gravity from the central black hole itself, no matter how massive it is. But in the last few years the scientists have discovered unusual objects known as ULX. Here is a short list of just some of them. And what makes these unusual objects somewhat intriguing, and this is once again ultra-luminous X-ray source, is the fact that in this case, the total amount of luminosity is dramatically higher than what's expected from the Eddington limit. Normally at least 10, but very often a few hundred times higher, with at least one such example right here in the Milky Way galaxy. This is a very famous object known as SS433, an object very likely containing some kind of a black hole, but also a supernova remnant that's producing this beautiful formation around the center. But the X-rays produced by this object are way too bright. But this other object, M82X2, is even more extreme. When it comes to X-rays, it's about 10 million times as bright as the sun and definitely surpasses any physical boundary for the Eddington limit, in this case by at least 100 times. which is exactly what this recent paper was able to confirm by doing more accurate observations using another X-ray telescope. In this case, the NASA's New Star telescope. And because in this case all of these objects seem to be tiny points in the middle of nowhere, it suggests that this is probably produced either by a neutron star or potentially some kind of a black hole. But the question is how? What exactly is happening here? And why do only some of them produce these very powerful observations? Well, there are at least two potential explanations, with this recent paper pointing at potentially just one explanation. So what exactly do scientists believe is happening? Well, the first explanations back in the days, a few years ago, suggested that maybe this is basically because of the orientation and the shape of various very hot gas produced around this black hole or neutron star. And so as these strong winds form a kind of a conic shape around the light source, they might be able to concentrate emissions in a certain directions in a specific shape that makes it appear a little bit brighter than it actually is. In other words, the first explanation was that it was some kind of an optical illusion, which I guess would explain how some of these objects could acquire super Eddington luminosities. But it didn't really explain everything, especially for this object. In this case, the scientists definitively calculated the total mass of the object and also the amount of material that seems to fall into the object in order to create all of these emissions. In this case, it was about 1.5 masses of Earth per year. And knowing this amount, the scientists can then theoretically estimate the total brightness in X-rays. Turns out it was approximately 100 times brighter than it should be, and that conical shape would be very difficult to use this as an explanation. Something else must be happening here. Also, this seemed to be not a black hole, but instead turned out to be a neutron star, and very likely a neutron star possessing very powerful magnetic fields. And it's very likely these magnetic fields that are the main reason for all of these observations and also provide that next explanation. In this case, the scientists now believe that super strong magnetic fields, very often present around, for example, magnetars, can actually physically change the shape of various particles, including super small atoms, sort of changing them into tiny long spaghettis from more spherical objects. And because of that change in shape, the pressure coming from all of these photons is now dramatically reduced because their surface area has also dropped as well. And so instead of all of these photons affecting something more spherical, they're now acting on something that's a lot more stretched and something a lot more elongated, thus allowing these objects to actually have much higher brightness because the photons in this case are not as effective at pushing things away. Which of course implies that whatever this is, or whatever these objects are, they must be super strong in magnetic fields where even tiny particles end up changing their shapes, spaghettifying as a result of magnetic interactions. And that's, by the way, just one of the unusual effects that these super powerful magnetic fields produce around neutron stars. As a matter of fact, there is a lot of other stuff that we discussed previously, including the concept known as magnetic birefringence, that sort of changes the space-time around neutron stars to kind of look like glass. And not just look like glass, act like glass. They sort of become crystallized right around their surface. Not to mention that it's also able to produce actual physical matter out of nothing. So whatever happens around neutron stars, even today is still super exotic and still kind of difficult to imagine and to understand. There's no way we can ever reproduce this in the lab, and these magnetic fields would be impossible to produce on Earth. But, theoretically, it's definitely possible, and that's of course that main explanation that the scientists now believe is responsible for these super bright objects. It's a kind of a mind-blowing explanation, because in this case, this object is literally changing the shape of not just any matter, it changes the shapes of even the smallest particles that try to approach this neutron star and possibly try to land on its surface. And that's of course the other unusual fact about neutron stars, something that's mentioned in the article from NASA in the description below. Apparently, even dropping a tiny marshmallow on the surface of a neutron star will result in an explosion equivalent to thousands of hydrogen bombs, because all of this marshmallow matter will suddenly convert into something else. You can read a little bit more about this in the article in the description. But anyway, very unusual phenomenon, strange explanation, but the only explanation that currently makes sense. Although once the scientists discover something else about ULX objects, or discover another one somewhere near us, I'll make sure to follow this up in another video. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.